section 7.1 is the cross products property. So you have to have a proportion, which basically just means you have one fraction set equal to another fraction. Okay, so A over B is equal to C over D. And you can't have B and D equal to 0, because if they were 0, then the whole fraction will be undefined. But then what you can do is a cross multiplication. So I usually circle them. Here they made the X to cross them out. So what that means is you could multiply A times D, and A times D would equal B times C. Okay, so the cross products property you usually probably hear as cross multiplying, but you will get AD is equal to BC. Okay, and then the properties of proportions. So if we have that same proportion we talked about above, it's equivalent to all of the following. So we just talked about how it would be equivalent to the AD equals BC, but then it's also equivalent to these equations. Let's think about how we can get from this equation here to one of these. If you have AD equals BC, what could you do to both sides? You could divide, right? So if you divided both sides by A, you could get B over A. And then if you divided both sides by C, then you'd end up with D over C. Okay, you could also divide both sides C here, and then divide both sides by D, and then you would get this other proportion. Okay, so all of these are equivalent to each other. So the proportion 1/3 is equal to 2/6. That means it's equivalent to all of these forms. This is really nice to see because you can see how the numbers are going to work out. So see how 1 times 6 is equal to 3 times 2? Yeah. And then we have 3 over 1, which would be 6 over 2. Doesn't 6 divided by 2 equal 3? Doesn't 3 divided by 1 equal 3? Yeah. Okay, and then here you have 1 over 2, which would be the same thing as 3/6. And we know that 3/6 does reduce to 1/2. Okay, so that's just showing you how they relate to each other. So when we set up proportions, there could be more than one way to set them up. So your proportion might not look exactly like somebody else's. In some cases, though, when you are trying to write a ratio, which you did a little bit of that earlier, they will have to be in a specific order. So again, a ratio is just another term for a fraction. Okay, so when it says write a ratio, you are going to be writing a fraction, and it's comparing two values. So for this one, you're writing a ratio expressing the slope of L. So in order to find this, what we can do is use our slope formula. So we have x1, y1, x2, y2, and then we're going to find the slope. Okay, so we know the slope equals the rise over the run, or y2 minus y1 over x2 minus x1. So in this case, I labeled my y2 as 2, so I'd have 2 minus 3. Oh, negative. Yes, yeah, sorry. Thanks. Yes, they did leave out the negative 2. Thanks for noticing that. And how could you tell that it was negative 2? Yeah, because of the quadrant, right? See how it's below? Okay, so it's negative 2 minus 3. And then I think your negative just got cut off because there is a space there. And then on the bottom, you would have 2, and this negative got cut off as well. So this should be negative 1. Okay, so we just put that in. So you have your negative here and your negative here. Okay, so if it's 2 minus a negative, what happens? You end up adding, right? Minus a negative is plus a positive, so this is going to end up, I do minus -1, and then I'll put plus a positive. So -2 minus 3 is -5, and then 2 plus 1 would be 3. So then your ratio is -5/3. Okay, so again, a ratio is just a comparison. Okay, and that's going to be in fraction form. So your ratio is just -5/3. All right, let's flip it to the second page. Okay, so for the second page, I want you to read and highlight any important information for example 2. Okay, so I just want you to read that quietly to yourself. I'm just going to give you about 10 seconds to read through that and highlight what you think is important or underline. Okay, and Logan, what's one part of this that you were thinking was going to be important here?
Side length of the triangle is 475.
Okay, so it's not necessarily the side lengths, but it is the what of the side lengths? Yeah, the ratio. Okay, good. So the ratio of the side lengths is 475. Okay, good. Caitlin, what's something else?
It gives the perimeter is 96 centimeters.
Okay, good. So your perimeter is 96 centimeters. And then another good thing is you always want to know what you're trying to find. Okay, so you are trying to find what is the length of the shortest side. Okay, now it's important that we understand that these are not necessarily the side lengths, but it is the ratio of the side lengths, which means we are going to have to put a variable with them. So if the ratio is 4 to 7 and 5, we're going to let the side lengths equal 4x, 7x, and 5x. Which one of those is going to be the shortest? The 4x. Okay? So those are what our side lengths are going to be. Now, if it's a triangle, if we're saying the proportion is 4x, 5x, 7x, how can I set these up in an equation with my given information?
You can add them up.
Okay, so the sum of them is going to be 96 because that's your perimeter. So I'm going to do 4x plus 5x plus 7x is equal to 96 centimeters. Okay, and then 4 plus 5 is 9. 9 plus 7 is 16. So then to solve for x, I'm going to do 96 divided by 16, which is going to give me the value of 6. Okay, so x is 6. Now we have to find the shortest side. So the shortest side is our 4x. Okay, so then we just have to do 4 times 6, which would be 24 centimeters. So that's going to be the length of the shortest side, is your 24 centimeters. All right, and then the next one we're going to go to, example 3, we're going to start solving proportions using that cross multiplication, that cross products property we talked about at the beginning. Okay, so using cross multiplication, Avery, do you think you could tell me what I would be multiplying together here?
Like 72.
Yep, so 7 times 72. Good, and then that would be equal to the 56 times your x. Okay, so if we do 7 times 72, we're going to get 504 times 56x, and then we'll divide both sides by 56. and you will get x is equal to 9. Okay, now let's say I wanted to do that without a calculator, right? Because we probably all did that with a calculator. Okay, so I'm going to show you how you can do it without it. So if you're solving this for x without a calculator, if you're solving this for x, you can think of this as 7 times 72 times 56x, and we would divide both sides by 56. So x would be 7 times 72 divided by 56. Now, do we know that 7 goes into 56? How many times? 8. So then that would reduce. What I would do is I would cancel this out. So 7 divided by itself is 1. 7 divided by 56 is 8. So then I'd have 72 over 8. And what's 72 divided by 8? 9. Okay, and if you didn't know that, you could also just keep dividing by 2. And then you could keep reducing until you got one that you had. Okay, so that's good practice. You guys will have your PSAT coming up here in a month. So we're going to start thinking more about how can I do these without a calculator. Okay? All right, and then for B, okay, for B, we are still going to use the cross product property. So Sam, what's one part of the equation I'm going to set up? Yep, tell me what I'm going to multiply together.
Z minus 4 and the other z minus 4.
Good, okay, so z minus 4 and z minus 4. Yeah, do you want to tell me what that's going to be equal to?
Z squared.
Oh, sorry, just the other side.
5 and 20.
Yep, 5 times 20. Good, yeah, do you want to tell me what this is going to be? We're starting it off, you did a good job.
Z squared.
Uh-huh.
Plus 16.
Oh, yeah, do you do that? Okay, I'm going to put it back here, okay?
And then the other side would be
So you,
100.
oh yeah, the other side would be 100. And then, so for this, you're going to have to FOIL. So z times z will be z squared.
Oh, yeah.
And then in the center, what would you have?
Negative 8. Oh, no.
Yeah, well, altogether you would. Negative 4z minus 4z. Yep, which would be negative 8z. So you'd have z squared minus 8z plus 16 equals 100. Okay, now this you can actually do a couple of different ways. So see how this is going to look like our factoring that we were just doing? Right? I could subtract 100 from both sides. And 16 minus 100 is going to be what? So count up, right? So it has to have a 4 in it because 16 plus 4 is 20. And then to get from 20 to 100, I'd have to have what? 80. So this would be negative 84. So now I can make my two brackets. So I have z and I have z. And if this is a negative, I know that what signs are going to multiply to a negative? Plus and a minus, good. Okay, so then let's make a t-chart for 84. So I could have 1 times 84, 2 times, if I cut 84 in half, what would I get? Good. Does 3 go in there? You know how you can tell right away? Yeah, so 8 plus 4 is? 12. Does 3 go into 12?
Yes.
Yep, so it'll go into 84. So let's find out how many times. Can you guys check that? So 84 divided by 3 is going to be 28. Okay. What about 4? Does 4 go in there? 21 times. Okay. 5?
No.
No. 6? How many times? 14. 7?
Yes.
12, 8, no, 9, we know that 10 doesn't, right? And we know that 11 doesn't. And then 12, see how 12 is already on our chart? That's how we know we found them all. Right? So because one's plus and one's minus, we want to find the one whose difference is 8. So if you subtracted 84 minus 1, 42 minus 2, etc., which one of these would get you 8 when you subtracted?
6 and 14.
Okay, so 6 and 14. So because this is negative, what has to be negative? The smaller number or the bigger number? The bigger number has to be negative to get a negative when you add. Okay, and then if you have z plus 6 times z minus 14 equals 0, see how these are multiplied together? So if you multiply two numbers together and you get 0, what do you know about one of these two factors? One of them has to be 0. So it's either z plus 6 that has to be 0 or z minus 14 has to be 0. So then I'm just going to solve each one for z. So here I'd subtract 6 from both sides. Here I'd add 14 to both sides. Do you guys remember doing some of this in Algebra 1? Okay, so those are going to be your two answers. I'm going to show you one more way that you can do this, and you might like this way better. Okay, so another way you can do this, see how these are the same? Z minus 4 times z minus 4. Okay, so then what you could do is write it as z minus 4 squared equals 100. And then to undo a square, what would you do to both sides? Square root. But when you square root, remember the square root of 100 isn't just 10. What is it? Plus or minus 10. So you would have to set up z minus 4 equals 10 or z minus 4 equals negative 10. So then I'd add 4 to both sides. And if you do 4 minus 10, you'd get negative 6. So see how that's a good strategy to use? Quicker than this when you have the 84. Okay, so you could use either one of those methods. All right, and then let's hop on over to the last page. Okay, so for example 4, you're using properties of proportion. So you are given that 18c is equal to 24d, and you have to find the ratio of d to c in the simplest form. Okay, that means if you have a fraction, you're going to reduce the fraction. Okay, so if you're given 18c equals 24d, you have two different choices. Okay, you can either divide both sides by 24 to get the d by itself. Okay, so if you divide both sides by 24, okay, on this side you'd have d, and then you have 18c over 24, which we can reduce. What goes into both 18 and 24? 6. Okay, so if you divide by 6, 18 divided by 6 is 3. 24 divided by 6 is 4. What you have is you have 3/4 times c, and you want to get this to the other side. So you're going to divide both sides by c. So then you'd have 3/4 equals d over c. Okay, so that would be one of your correct answers. Another correct answer, or a way that you could do this, would be if you have 18c equals 24d, if you want, what you could do first is divide by c. So 18 would equal 24 times d over c. And then you could divide by the 24 next and reduce. Okay, so in both cases, notice that if the ratio is D to C, the D is on top. And the C is on the bottom. Okay, so D to C means that you have to have D over C. Yes.
I don't understand this. So up in what it's given, it says that 18C is equal to 24D.
Mm-hmm.
So how is it? I guess I'm confused because it's 3 over 4 equals D over C, but how I got it, it's flipped, so it's 4 over 3.
And then, but then did you get C over D?
No.
So if you did flip it, because if you divided both sides by 18, then you would have C over D. So like if you did, because did you say that you divided both sides by 24?
I put them over because it's D to C, so the ratio I found would be 24 over 18, and then I divided both by 6 because that's the GCF.
So in order to get your ratio, you would have to divide both sides by C first to get your DC.
Okay.
Really, you could divide both sides by 24C so that this would cancel out and you'd have D over C right away, and then your C's would cancel out here, and then you would divide them both by the GCF 6, and that would give you your 3/4.
Okay, that makes more sense.
Okay, yeah, you're welcome. Okay, and then our example 5 is our problem solving application. So we have Marta who's making a scale drawing of her bedroom. Her rectangular room is 12.5 feet wide and 15 feet long. On the scale drawing, the width of her room is 5 inches. What is the length? Okay, so there's an actual room, and then here's her drawing. Okay, so it's like a model of her room. So it's 15 feet long, so this is my longer side, and it's 12.5 feet wide. Okay, now for the drawing, and I labeled these. This is the room, this is the drawing. Okay, it says the width is going to be 5 inches. Okay, what we have to find is the length in inches. So the length I'm going to call X. Now, notice here that if this is in feet and this is in inches, I'm going to have to convert. I'm either going to have to convert the feet to inches or the inches to the feet. What are you guys thinking you'd want to do? Yeah, the feet to inches is definitely going to be easier. So we are going to convert feet to inches. Okay, so you have to have the same unit of measurement. Okay, so how do I change 15 feet into inches? Okay, multiply 12. Brandon, why do we multiply by 12? Okay, so there's 12 inches in 1 foot, so we're going to do 12.5 feet times 12 inches, which is going to give you 150 inches. Then we're going to convert the 15 feet into inches, which will be 180 inches. Okay, so this is 180 inches. This is 150 inches. Now that we have the same units, okay, what we can do is we can set up a proportion. Okay, so the room is going to be compared to the drawing. One way that you could compare them is you could do the width over the length, and that would equal the width over the length of the drawing. You could also flip that. You could do the length to the width, okay, for both of them. That would be fine. So now I'm going to plug in what I know. So the room, the width of the room is 150 inches over the length, which is 180 inches. And then the width of the room in the drawing is 5 inches. And then here's my length. Okay, so I can use my cross product rule to multiply. So I would do 150 times the length equals 180 times 5. So 150 times the length, I'm going to leave it like this, and I'm going to divide both sides by 150 so that I can reduce this without a calculator. Because if you have 180 divided by 150, what cancels out? What cancels out here? The zeros, right? You can divide by 10. And then look, I have 5 and 15. Are those going to reduce? Yeah, how many times is 5 going to 15? 3 times. So now I have 3 on the bottom. Okay, and then I have 18 over 3. What's 18 over 3 going to be? 6. Okay, so the length of the drawing is going to be 6 inches. All right, so your homework for today is going to be 7.1, 3 through 29, and then you're going to skip number 27, and that is on page 457. Okay, and again, I want you to notice that your next quiz is less than a week away, so it's next Wednesday. And that's going to be over 7.1 to 7.3.